Okay, hello, this is Miss Bettis again with our notes on our next lesson, synthetic division. And so synthetic division is the lesson that follows long division, which we learned in class yesterday. But synthetic division is a shortcut for dividing polynomials by specifically binomials in this format, x minus k. So we cannot have a coefficient in front of the x. It cannot be a trinomial. It can only be binomials as our divisor in this format. Okay, so here are the steps. It says first, write the binomial divisor x minus k by placing k outside of an L bracket. Now, this is where you're going to put your k value. Notice this says negative or x minus k, so then you will take the, it's kind of like you have to change the sign and put that value right here. Okay, let me get the pen. Alright, so that goes on the outside. Now, synthetic division doesn't have to look this way, and depending on what text or video or notes you're looking at, people may write them different ways, like this. Okay, and then you'll put your k in a little house. So it could be set up in different ways. Alright, so that's the first part. It says next, arrange the coefficients of the dividend on the inside of the bracket. Let me get my focus right. Hold on. Okay, there we go. It says arrange the coefficients of the dividend on the inside of the bracket. That means that if this is the polynomial that you are dividing, you will take the coefficients of each term. So here you'd have a 1, here you'd have a -2, -8, and finally a -35. And those would be the numbers that are arranged here at the top. Okay, so I would have a 1, I'd have a -2, I'd have a -8, and a -35. Okay, so that's why it's called synthetic. It's because we've now removed the variables, we have removed the exponents, and all we are dealing with are the coefficients. You put your k value from your divisor on the outside, and you string your coefficients from the dividend across the top here. Very important note, just like with the long division, you have to include any zero placeholders for terms that are not represented. Okay? Alright, well, how does this work? Well, let's look at this little info box to explain the process. So here we have x minus 5 as our divisor. So I'm going to use my k value and place it in the house, or in this little window, or on the outside of the bracket, okay? But 5 is the number that goes here. Not -5, but 5. Alright, so here we have our coefficients aligned. So there's 1, -2, -8, and -35. The same as the ones that I had strung across the top here. So step 1 is to bring down that leading coefficient. So that leading coefficient will just come down below this line. Our process is to now multiply the number that we have in the little house with that leading coefficient. And that product will now go up underneath our second coefficient. Okay? So I have the number on the outside. I'm going to multiply it with that coefficient, leading coefficient that I brought down. And that answer goes underneath our second term. And then we'll just add these two together. That answer comes down below the line. And then we repeat the process. We will multiply our 5 in this case with that 3. And then we'll bring it up. So what we're doing is we are repeating this process of bringing the number down, we'll multiply, and then we'll add. Bring the number down, multiply, and then we'll add. Alright, now, I'm not going to finish that because it just looks better and we understand it better when it is in actual practice. So here's our first example. It says -x to the third plus 4x squared plus 9, and we're going to divide that by x minus 3. So this is our divisor here. Alright, so I'm going to build my little house, and here's my line. So in the house, I'm going to take x minus k. I want my k value, so that's going to be a 3. Alright? 3. Not -3, but +3. Our coefficients, and let's make sure that no terms are missing. So I have a cubed term, coefficient of -1. My squared term, coefficient of 4. A linear term is missing, so I need to put a 0 as a placeholder. And then my constant is a 9. Okay, so there they all are. -1, 4, 0, and 9. So this leading one always comes down. Okay? I'm going to multiply 3 with negative 1, and I get a negative 3. It goes here underneath the 4. Now I add. 4 minus 3 is a 1. And then repeat the process. 3 times 1 is a 3. And then I add, and my answer here is a 3. Lastly, 3 times 3 is 9. And then I add, and my answer is 18. Okay? So now we are wondering, well, like, what does this all mean? Okay? Well, let's talk about what this all means. These values that we have underneath in our synthetic division are the coefficients of my quotient. Okay, and you're like, Miss Bettis, what? These are the coefficients of my quotient. My initial problem started off as a cubic. In synthetic division, I know that my quotient is going to be 1 degree less. So, my quotient is negative 1x squared plus, this is now linear because 2, I'm going to go down to a power of 1. So this is now 1x, and then plus 3 is my constant. The 18 is a remainder. Okay? So your quotient, you are going to have to mind your degrees, okay, so that you can know what variables and what exponents to align with these coefficient values. So these numbers only represent coefficients. Negative 1, a positive 1, and a 3 here is my constant. That last value will always be your remainder. Okay? Sometimes it'll be 0, and then there won't be a remainder at all. But if it is, then you just place it as a remainder. All right, one more time. Let's do this again. So here I have negative 2 as the number that goes in here. And my coefficient, so cubic, that's a 1. Quadratic here, that's a negative 3. Again, there's no linear. And then finally I have the constant. All right, so we'll bring the 1 down and let's start. 2 times 1 is 2. Negative 3 plus 2 is negative 1. 2 times negative 1 is negative 2. Bring that down, that's a negative 2. And lastly, 2 times negative 2 is negative 4. And when we add, we get a positive 3. So what's our quotient? Oh, x squared minus x minus 2 plus 3 over, and we keep this divisor here, x minus 2. That is it. That is synthetic division. And if you don't believe me that this is accurate, well, you know what you can do? Set it up as long division and prove it to yourself. Do this problem and see if you get the same thing as what we have right here. All right, that is it for our lesson today. What we're going to do in class that you're going to miss because you're not here, we are going to do these practice problems. You can ignore the partner part. The answers probably won't be the same. But we're going to do these problems here. We're going to talk through these understanding questions just to make sure that you understand how this works. And if you have any questions, please email me. Feel free to reach out via email. And your homework for tonight will be the next pages in your booklet. Practice worksheet, synthetic division. Here we have some boxes for you to complete. We have some problems here for you to answer. And we have these 4 questions here for you to complete as well. Have a great weekend. See you Monday.